So in this video we want to introduce the idea or concept of a function. And a function just happens to be a special type of a relation. So if something is a function, then it is a relation. So we've been looking at relations in the last few videos, and we've indicated that a relation can be identified with ordered pairs, and that these ordered pairs correspond to inputs and outputs, or an independent variable that results in a dependent variable. So a function is just a specific type of relation where if we have an element from the domain, and remember the domain is just our representation of the valid inputs for the function or relation. So each element or each input pairs with exactly one element from the range, and remember range is just how we identify the possible outputs. So essentially what we're saying is, as long as the relation has the characteristic that each input generates only one specific or unique output, then we have a function. So the way that I like to kind of explain this is in terms of a pop machine. So let's say you have a soda pop machine. And let's suppose that our inputs are the buttons on the pop machine. So here's a button. And then to make it easy to talk about this button, I'm going to call this as button number 1. And maybe button number 1 gives you water. So we'll put H2O on there. And then it has another button. And if we push this button, we get a Coke. And we'll call this button 2. And if we push this third button, we get a Sprite. I don't know, is Sprite a Coke or a Pepsi product? So the inputs are the buttons, and the outputs are the drink or beverage that you get when you push the appropriate button. So I could actually represent my pop machine using ordered pairs. I could say, hey, button 1, when you push button 1, there's your input. The output is that you get water. And when you push button 2, your output is that you get a Coke. And when you push button 3, the output is that you get a Sprite. So in this case, our domain would be button 1, button 2, and button 3. And our range would be water, Coke, and Sprite. And in this case, this relation between buttons and beverages would be a function relationship, because each button or input or element in the domain corresponds to exactly one element in the range, or exactly one beverage. I push button 1, I get water, and I only get water. I don't get water or Coke. I don't get water or Sprite. I just get water. When I push button 2, I just get Coke. When I push button 3, I just get Sprite. This element in the domain corresponds to a unique or exactly one element in the range. It's okay on a pop machine, so you as a user of a pop machine are perfectly happy if button 4 also gives you a Coke, and button 5 also gives you a Coke. And in fact, the way that most pop machines are constructed is that the beverage that is vended the most by that machine has the most buttons, because they stock more of that beverage in that machine. So it's okay if there's a button 4, and button 4 generates a Coke, and button 5 generates a Coke. This is still a function relationship, because each element in the domain generates exactly one element in the range. Button 2 generates only Coke. Button 4 generates only Coke. Button 5 generates only Coke. This is a function. It's okay for more than one button to generate the same output, but we don't want one button to generate multiple outputs. So for example, what would make this relation between the inputs or buttons and the outputs or beverages, what would make it not a function is exactly the thing that would annoy you if you use this machine. So let's say button 1 misbehaves. Let's say button 1, when you push it, sometimes gives you a water, but sometimes it gives you a Coke. So that when you push button 1, you might get water, but it's also the case that when you push button 1, you might get a Coke. So in the mathematics world, this would not be a function. We would say, look, this input, button 1, shows up in more than one ordered pair, generating more than one output. In other words, an element in the domain, button 1, doesn't correspond to exactly one element in the range. Instead, it corresponds to two elements in the range, water and Coke. This would not be a function. And in fact, you as the user of this vending machine would say that this vending machine does not function properly. You would be annoyed if you wanted a Coke and you pushed this button and you got a water instead. So this wouldn't be a function. If we allowed one button or one input to generate multiple outputs, we would say, well, it's a relation, but it's not a function relation. So as long as we say, hey, each button or each input generates a well-defined output, exactly one output, then we have a function relationship.